Hi, Geometry. Mr. Manor here. Going to work with you on section 9.4 and 9.5 combined when we actually get into the story problems. So before we start, I got a joke for you. Brought to you by Mrs. Ortman's daughter, Paige. Why didn't the toilet paper cross the road? Or why couldn't the toilet paper cross the road? Because it was stuck in a crack. Yeah, that'll start your day off right. So this is the last day of learning this week. I take that back. This is going to be for Monday. Sorry about that, but we will get started anyway. So trig application problems. There's your essential question, how I set up and solve trig application story problems. Got SOHCAHTOA over here. We're going to do a couple of review problems first on sine, cosine, and tangent. So let's start here. We got 63 degrees. I have an opposite side that I'm looking for. Hypotenuse that I know. So I have an opposite side I'm looking for. Hypotenuse I know. I'm going to use sine. S means sine. So sine, I always write the angle after the trig function, equals opposite over hypotenuse. All right. So I take my calculator now, or you can use decimals. It doesn't matter. All of them work. If you've been using decimals, use decimals at the point. Sine 63. Put that in. That's 0.8910. 0.8910. 0.8910 equals x over 50. We're going to put that over 1. We're going to cross multiply. So we're going to take that 0.8910 and we're going to multiply it by 50. All right, so that's 44.55 equals x, because it's x times 1 is x. 50 times 0.8910 is x. So this length is 44.55. That should make sense because the hypotenuse is the longest side of the triangle. So this 50 here, longest, this is be shorter than it. Coming over here, I have angle 25. I have opposite and adjacent. Hypotenuse is over here. I don't have that one, so I'm looking for opposite and adjacent. So I have tangent right there. So tangent. Always write the angle next. 25 equals x over 15. Use our calculator. We type in tangent 25, and we get 0.4663. 0.4663 equals x over 15. Put that over 1. Get ready to cross multiply. We'll take that number, multiply it by 15. We'll have our answer 6.99. So x equals 6.99. Let's see, would that make sense? Yeah, because this angle will be 65. The sum is 180. So 25 is a small angle, should be a small side. 65, larger, so it should be larger. So 15 should be larger than x, and indeed it is. The last one we have 32. I've got adjacent. I have hypotenuse. So cosine, adjacent and hypotenuse. Cosine 32 equals x over 24. So I'll take my calculator. I'll type cosine of 32. I'm going to end up multiplying that by 24 once I cross multiply, which says 20.35 should be my answer. X equals 20.35. All right, that does make sense. Hypotenuse is longest, so x should be a little bit shorter than that, which it is, 20.35. All right, now you have a quick SOHCAHTOA review. Now we're still going to use SOHCAHTOA. Today is just going to set up story problems. So you may see a story problem like this. So we have a ladder leaning against a building that makes an angle of 42 degrees with the ground. The trouble with these problems, you got to be able to draw them. If you can draw them, you are ready to go for SOHCAHTOA. So it's going to lean against this building, right? So you have this building right here. I'm going to put B for building. There's my ladder leaning against the building. This is my ladder right here. It says the ladder is 30 feet long. Okay, so that's the ladder right there leaning against. So this would be called a side view. We're looking at this from the side, and you see a ladder. So if somebody's going to climb the ladder, they would climb up it like this, and they're going to climb up a 30-foot ladder. It says it makes an angle of ground with the ground of 42 degrees. So here's the ground, here's the ladder, and it makes an angle of 42 degrees together. And it asks us, what is the height the ladder reaches up the building? Because a 30-foot ladder isn't going to go 30 feet up the building unless you set it completely straight up and down. Well, we need to know how high it'll reach. So if it's going to reach up to a window, we need to work on or paint the house or something. Or the building, I'm sorry. So now we can do our SOHCAHTOA. So I have opposite, I have hypotenuse. So I'm going to do sine 42 equals x over 30. So when I do this, I got sine of 42. That's going to be times 30 because I'm going to cross multiply it. And there's a little glare on that, 20.07. X equals 20.07. That makes sense. It's less than 30, which is the hypotenuse. That should be the longest. All right, some new vocab words for you today. Angle of elevation. Angle of elevation, the clue is elevate. So that means up, because you're on an elevator. Think about an elevator going up. Now, an elevator can go down too, but if something's elevated, it means it's up. So what that is from the horizontal, it's how far we go up from the horizontal. So if you have the horizontal, it's the angle that we go up. All right, so this right here, that angle is called the angle of elevation. So if you want to write it out into words, it would be from the horizontal up to object is angle of elevation. From a horizontal up to the object, right? So if you're going to look up to some object, let's say there's a little bird in the sky or something, and you're going to look from the ground up at your angle of elevation. So here's your ground, your horizontal, up to whatever object you're looking at. So that is the angle of elevation. Angle of depression, so depress is to go down. So if angle of depression would be like this, you would be the person on top of the building, all right? So you'd be on top of the building up here, and you would be looking down, all right? So you'd look down, that would be the angle of depression. Now, angle of depression is from the horizontal down to the object is angle of depression. All right, so let's say you're going to look at a squirrel on the ground. We'll just label it S for squirrel because I can't draw a squirrel. So this one's a little tricky. Angle of depression is from the horizontal, so you'd be standing on top of a building from the horizontal down. So this right here is the angle of depression. Right, so that little angle in there is angle of depression. Notice that angle is not in your triangle. If this is the triangle we're working with here, I need to get this angle in this triangle. So to do that, I rely on an old geometry rule that you learned in chapter 3 a long time ago with Mr. Spiels or Mrs. Kroll. This angle right here is alternate interior to this angle down here. So whatever the angle of depression is, it's also going to be the angle of elevation, which is alternate interior. And alternate interior angles are congruent if the lines are parallel, which horizontals will always be parallel. So this angle equals that angle. I'll show you how that works when we get into a problem. Let's do a couple practice problems, and then you'll be all set for the practice. So there's a passenger jet that's 5 miles from an airport. We're going to say 5 miles ground distance from an airport. And it'll be labeled clearly if you take a quiz on this. The angled elevation from the landing strip to the jet is 10 degrees. Now, again, I can't draw a jet very well, so I'm just going to do this because I like to cheat. So we'll just call that a jet up in the air, right? Passenger jet's 5 miles from the airport. So here's the airport, A for airport. So the jet is 5 miles ground distance from the airport. All right, so here's my jet. You'll always draw a right triangle with these every single time. You get a right triangle for sure. So 5 miles right there. That's the ground distance. So the jet's distance to the airport is 5 miles. Okay. It says the angle of elevation from the landing strip to the jet, right, is 10 degrees. From the landing strip to the jet, 10 degrees. So this is the angle of elevation. So if you were on the landing strip and you looked up to the jet, you would have 10 degrees. So what's the altitude of the passenger jet? 5,280 feet in 1 mile. Let's see, does it ask for the altitude in feet? It does not. Oh yeah, I'm sorry, in feet. Missed that completely. So that means that we're going to look for this, but we're going to look in feet. So I'm going to switch this over here. I don't want to work in miles here. I want to convert that over. So to convert that over, I'm going to take 5 times 5,280. And that should get me the number of feet, the ground distance, 26400, that the airplane is to the jet, or the landing strip is to the jet. So I converted in feet right away. So instead of using this 5 miles, because it asked for an answer in feet, I'm going to convert my numbers and do it that way. Okay, SOHCAHTOA is our friend. So it looks like we have opposite, adjacent, tangent, 10 degrees equals x over 2640. Tangent 10 equals x over 2640. Let's solve that problem. Tangent 10. I'll go pretty quickly on the trigonometry because we've done a lot of this. Oops, 26400 times 26400. Oop, too many zeros. Not enough, then too many. All right, let's try that one more time. Tangent 10 times 26400. Got it. No, that's not right. Mr. Manor, you're goofing up. Tangent 10, enter, times 26400. There we go. 4655 feet. So that jet has an altitude of 4,655 feet. Okay. All right. Moving on. So we got a passenger jet at an altitude of 3,000 feet. So this is a little bit different. They're going to give you the altitude. The altitude is at 3,000 feet. Right, so that's altitude is the vertical distance. And the navigator finds the angle of depression to a radio tower. So here's the jet. Well, there's our jet. Here's our radio tower. And there's an angle of depression. So remember, the angle of depression is going to be outside my triangle. So that's my angle of depression. Remember, that comes from the horizontal going down to whatever I look at. As I mentioned before, the angle of depression is the angle of elevation. So these two will be the same. And then it says how many feet beyond the radio tower. Let's say how many feet, and we'll say that is ground distance. Beyond the radio tower is the passenger jet flown. All right, so the jet's flying this way. It goes past the radio tower, and that's what we're looking for. It's the ground distance. Looks like tangent again, so I have opposite and adjacent. Tangent 20 equals 3,000 over x. So let's do a little cross multiplying. This one's got a little extra step for us here. So let's put in tangent 20, which is 0.36397. I'll use all the numbers if I can. Always use all the numbers if you can until the very end. So it's 0.36397x equals 3,000. Cross multiplying. And we're going to divide both sides by 0.36397. So I'm going to take my calculator and I'm going to go 3,000 divided by 0.36397. Of course, my kids are screaming, yelling in the background. 8242. So the nearest foot, x equals 8242 feet. So that would be the ground distance that they found here. Okay, plane is 3 miles above the ground. I'll just keep right on going. So we have a plane or a jet 3 miles above the ground. Pilot sights the airport at angle of depression of 15 degrees. Okay, and it's looking for the ground distance. That would be here. 15 degrees is going to come into our triangle right there, 15 degrees, because it's alternate interior, parallel lines. So I'm going to do tangent again. Tangent 15 equals opposite over adjacent, 3 over x. I'm going to cross multiply. So as you saw in the last problem, what I'm going to end up doing is taking 3 and divided by tangent 15. That's 11.196. 11.196 miles. So x equals 11.196 miles. And last up, a surveyor is 130 feet from a tower. So here's a surveyor. Here's the tower. He's 130 feet. Oops, 130 feet tower. The angle of elevation of the top of the tower is 32 degrees. 32 degrees. The surveyor's instrument is 4.75 feet above the ground. Oh, so we got a little bit of a mess to work with here. So that means the surveyor's instrument is 4.75 feet above the ground. Okay, we'll see if we can figure out how to do that. What's the height of the tower? So we'll be able to find x by using some SOHCAHTOA, and then we'll have to add on this 4.75 for the height of their instrument when we're done. So we will use some SOHCAHTOA. Tangent 32 equals x over 130. Tangent opposite adjacent. So it is tangent 32. So we're going to cross multiply that times 130. So tangent 32 times 130. I got 81.23. So x is 81.23 feet. All right, now that's not the height of the tower because that's just this length here. We have to add on this little length here. So we're going to take 81.23, we're going to add 8.75 feet to that, leaving me with a grand total plus 8.75. 89.98 feet. 89.98 feet. So the height of the tower was this length plus however far the instrument was above the ground, 89.98 feet. Okay, I hope that helps, and have an awesome Monday. Talk to you soon.